Hey everyone, in this video I will be discussing about associative arrays in details with the help of few examples. So let's begin. So like dynamic arrays and queues, associative array is also of unpacked type and it is the slowest one but it has its own advantages. So firstly, how do we declare an associative array? So we declare it like this. So the first thing should be the element type and then the name of the associative array. Let's name it ASSOC underscore AR. And then it has a special functionality. So associative array allows you to have non-standard indices. It means the indices can be of any other data type other than integer that you will find in the regular arrays, dynamic arrays and queues. So if I want, I can mention the indices data types here. So suppose if I want the indices to be of int, I can mention int here. And if I want the indices to be of string data type, I can just simply write string right here. So let me walk you through with an example to help understand better. So let's name the module. So here I have named my associative array, and the indices of this associative array will be of string data type, whereas the element will be of int data type. So they will be of 32 bits. So here I will demonstrate you that how can we assign any value to any element of associative array. So to assign any value to any associative array, it is very simple. So right now the associative array is empty, and also I would like to create a separate initial block to monitor any changes inside associative array. I will just use %p and I will mention the associative array. So this $monitor will continuously monitor for any changes inside this associative array, and if it detects any changes, it will just print the value right on the console. So first, I will assign some value to associative array. So since our indices should be of string data type, we can assign any value just by writing the array name, and then within the square bracket, we have to name that particular string indices we want to have as an element inside this associative array. So for this example, let's say I will be writing ABC, and ABC equals to, and since the element should be of int data type, I can just write any number. Let's give 12. So this will store indices, index that is an index of name ABC, and that index will have a value of 12, which is an int data type. So let's go ahead and check for any compilation error. Okay, the code is error free, so we will go ahead and simulate the code. So as you can see right here on the console that the associative array shows one element and the index of that element is ABC, which is of string data type, and the element or the value associated to that index is 12, which is of int data type. Similarly, we can assign some other value. So let's give it, and the second index should be XYZ, and let's give that 1. We will go ahead and simulate the code for one more time. So as you can see right here that we have added another element and the index of that element is XYZ and the value associated to that index is 1. So this is how we can have non-standard indices and we can assign any value to them by using this method. So associative array becomes really useful for cases where the elements or data inside a data structure is sparsely distributed. So let's say we have a huge data structure with lots of elements. So if each of the elements are not utilized, so for such cases, using a regular array such as dynamic array will be very insufficient. So for those cases, it is better to use associative array because in associative array we can assign the values as per the requirement. So for example, if we have a cache which can store data of 64 bits, so we will just write bit cache array, and we can write, let's give the index type to be int. So suppose we have few cache hits and few of the locations. So instead of using the regular array, we should use associative array because it will only store the elements which are hit, and it will store the index of that element and the value of that element. And instead of that, if we have used a regular array like this, so this will become very inefficient because suppose if we are only utilizing, let's say, Oh, just wait a second. It should be of 64-bit. And here we have to mention the actual number of. So in this, if we are only storing data to, let's say, 2 or 3 elements, so the remaining elements will still get built, but it will be empty. So using that will be very inefficient. So instead of that, we will be using associative array. And let's say if I want to assign any value, let's say at the 100 location, I can do that just by writing hash, and I will name the index number 100, and in the 100th address, I am storing some data. Let's give it anything. So this makes it very efficient, and we can just monitor the value using the same way. So first let's check for any compilation error. Okay. So as you can see right here that this particular associative array has stored data 71, which is of 64-bit, and it has stored that data at the 100th location. So the entirety of this array only contains this particular data. So let me take you through another example. So using a simple repeat operator, I will assign some values to each elements of an associative array. So first let's declare the associative array. I want it to be of 32 bits and just name it as, and the index data type should be int, which is of 32 bits. So inside my initial begin, I will just use a repeat operator. It's not an operator, by the way. So using repeat, I will assign 32 values. So here, what I will do is that I will mention another integer or a 32-bit variable, and I will name it index or IDX, and I will initialize the value to be 1. So this associative array will begin with index number 1, and it will repeat that for 32 times. So for index number 1, it will store 1, and what I will do in the next line, I will shift the IDX bits by 1 to the left side, so it will get a power of 2. So in the next iteration, the index will be 2 to the power 1, and the value will be 2 to the power 1, which is 2. And then it will happen again. Then on the next iteration, the index will be 2 to the power 2, and the value will be 2 to the power 2. So it will keep happening. The index will keep iterating till it gets to 2 to the power 31, and to the index 2 to the power 31, the value 2 to the power 31 will be assigned. So let's just compile the code. Okay. So how many ways are there to display the value of each element? So for this particular case, the simplest way is to use a for each loop, and inside for each I will just iterate through every element of this associative array, and I will display the value using $display. So I will go ahead and simulate the code. So as you can see right here that it begins with the 2 to the power 0, that is 1, and our initial value of index was 1. So it then get the next power of 2, that is the 2 to the power 1, which is 2, and then 2 to the power 2, which is 4, and 2 to the power 3, which is 8. Similarly, it just kept going until it reaches 2 to the power 31. So this is how simple it is if we want to iterate through the elements of an associative array. But remember one thing, that Associative array has a feature that the indices can be of non-integer data type such as strings. So for such case, how can you use for each loop using this local variable? So for such type of case, it is impossible to do that. So allow me to show a method to iterate through each elements of an associative array without having the trouble of printing each elements by calling them on each statement. So it is very simple. So what I will do, I will just remove this for each and I will write a if else condition, only a if condition, and inside that if condition the argument is so this is my if condition and I am using the first method. So the first method simply returns and simply assigns the first element inside its argument. So here I have assigned the argument to be idx, which is of int or a bit 32-bit type. So what this will do, if there is any element or there is a first element which exists in this associative array, it will simply just assign that value to idx and this argument in total will return 1. That is true. If there is no elements or like you are not able to find the first element inside this associative array, the argument in totality will return false or 0 and idx will not get any value. So this is my if condition. So if this condition satisfy, so I will begin and inside begin I will write a do while loop. So the condition of do will be very simple. It will just display the elements and it will keep on displaying elements until the while condition fails. So it will keep displaying the elements. So here you can see if the condition pass, the IDX will have that the index of that element and using that index we can just display the value. And it doesn't matter that the index is of what type because here it is sure that it is for sure that the index is of integer type. But for an associative array where the indices are of string type, then this variable should be of string type. So here it supports our this particular case, so we are not making any changes to this. And what here it will do that it if it becomes true, it will just execute this display statement until it reaches the last element. And how do we determine that whether we have reached the last element? We can do that simply by using the next keyword. So this is very simple. So what is happening right here, that this next method, if there are any elements to the next index, uh, to this index which is currently recorded using the first method, then this method will store that next index to that variable, and it will return true. So what is happening in total is that first it will check for this condition using the first method. So if there exists any element, it will record the index of that element and it will assign that element or store it to this variable. And what it will do, and that particular condition in total will return true. So after this condition is satisfied, which will be satisfied for this case because we have lots of elements, it will execute this do statement, which is just a display statement, which is printing the element which is associated to that particular index. And after that, it will just hang on with this do while loop. So what while loop will do, it will check whether there exists the next element. If there is a next element, then it will store the index of that next element to the very same variable and it will return true total. So again, that do statement, the display statement inside that do will execute again. And this will keep on going until we reach the last element. So for the last element, the dot next method will fail because there won't be any next element and we will go out of this do while loop. So this is the most simplest and efficient method of iterating through index or indices which are of other data type other than string, other than int, such as string. So let's go ahead and check whether this works for our case or not. So first I will check for any compilation error. Okay, it does have compilation error. So let me have a look. Okay. Oh, what I am doing here. This should be a curly bracket, a round bracket, not a curly bracket. So I will check for the compilation error. Okay. Okay. Oh, damn. So this was a very stupid mistake. Let's check again. Okay. Now we will go ahead and simulate the code. So as you can see right here that it is working just fine. So this is very important for cases in which our indices are of non-standard data type. So in the next video, we will go through with more examples with different complicated conditions and how to solve them for associative array. So stay tuned for more. Thank you so much.